Hello everyone, my name is Rishabh Sinha. I am a BTech final year student at Delhi Technological University, and on behalf of my fellow authors Sonal, Ritik and Anamika, I am going to present today the paper titled A Detailed Insight into News Channel Debate Analysis. I would like to start with a quote that I think we can all relate to. It's not that we use technology, we live technology. This perhaps is the most accurate description of the world and era we live in. Technology has given immense power to every individual and the society as a whole as well. We utilize the various state-of-the-art facilities to help organize our lives in a better and simple manner. Among the widespread applications of technology, one of them is the ability of technology to connect the world and let people know what's happening in the other parts of the world. But rarely do we ever stop and think about the accuracy of the news presented to us. Slowly but surely, what we see and hear become a part of our personality and most essentially a part of our community we live in, and therefore by extensions the community's ideology and creed. This is what makes the digital media a double-edged sword, that too a very delicately balanced one. Hence, it is very important for us to look in retrospect and ask ourselves, when do we inspect the source of our beliefs and our principles? Debates conducted by news channels form a small section of information propagated by media that affects the masses. The best way to analyze these debates is to use NLP and ML techniques in tandem to reach a meaningful conclusion. The study traverses a few functionalities of NLP to help understand how this cutting-edge technology can be used for getting insights down to every little detail. The central idea of this paper was to go beyond the surface and delve deep in order to perform a microanalysis of the debates held by various channels. Although the debates are available in the public domain, such an analysis has not been carried out. It demonstrates the immense use of NLP and ML techniques in the various fields. We have surveyed a number of papers related to such analysis conducted over the years. Over here, we discuss the most relevant ones. The 2016 paper, titled Statistical Topic Modeling for News Articles, used LDA for topic modeling. The primary objective of the paper was to discover the main topics of the newspaper articles corpora. This work is focused in predicting the topic for a given document using observed keywords. In this paper, the author uses Stanford Topic Modeling Toolbox for topic allocation of 400 news articles. The paper then analyzes these results and gives us the possible conclusions. The second paper, called How the Pandemic Spreads in News Text Analysis Using Topic Modeling, is perhaps the most relevant one for our paper as well. It discusses one of the most burning themes in recent times, the COVID-19, and how it was perceived and channeled by the most prominent news websites like CNN and BBC and their articles. The paper describes the phenomena as a media infodemic and tries to reach some conclusions regarding the topics people are most interested in by using LDA for topic modeling. The paper makes use of coherence metric for getting the optimal number of topics. Each topic is then described based on top 7 words within the topic. After both the allocations, the author then discusses the findings with context to the dataset. The paper Smart Literature Review, a practical topic modeling approach to exploratory literature review, aims to create a foundation for researchers to reduce the work of manually labeling a research paper into a category. It harnesses the LDA technique again for topic modeling to perform an exploratory literature review in a faster, more transparent, and reliable way than manual exploration. It provides a good use case as the ease of use for modeling and the swiftness of the framework over the manual process seems very promising, although it does have a few limitations. The paper, A Multimodal Approach for Early Detection of Cognitive Impairment from Tweets, brings forth a novel approach to attempt to detect and solve the problem of cognitive impairment. The author infers that the tweets shared by a person can be a source for identification of the condition. The paper utilizes NLP and ML concepts such as Levenstein distance and fuzzy matching to score the tweets indicating the degree of cognitive impairness and thus profile the person accordingly. It hypothesizes that if we are able to detect cognitive impairment at an early stage, we can prevent diseases such as Alzheimer's. In the last paper, Examination of Fake News from a Wild Perspective, it discusses a new framework to the problem of fake news detection. It introduces new parameters like sentimental resonance and emotions to help predict fake news. It also analyzes the impact of association of content and news article titles attributes such as length on the probability of news being fake. We now proceed towards the tools and technology used in our study. First is non-negative matrix factorization or NMF. It's used for topic modeling and it's an alternative approach to LDA that we have used with TF-IDF factorization. Second is TF-IDF. It's just a basic numerical statistics to reflect how important a particular word is in context to the corpora. We've used TF-IDF in place of count vectorizer as the preferred technique for word vectorization. The classification algorithms for text classification, we have used SVC and it's the most widely used algorithm and it gave the best results compared to other algorithms. Web VTT or VTT, this library is the pivot of our study as it has enabled us to directly access the transcript of the debates using a simple API call. For most of the debates, we are able to extract the transcripts. Lastly, we use the bouquet library for all visualizations. It provided simple, concise graphs and interactivity to help user gain insights. We have divided the study into three phases. In the first phase, we follow five major steps. In the first step, we acquire the raw data from the YouTube videos of channel's official page. Then, with the help of Web VTT module, we extract the transcript. 1600 debates were taken for the study. In the second step, we clean the raw text, pre-process it by removing stop words and punctuations. The list of stop words spanned to 4500 in length approximately. We did not lematize or stem the words, as some words would have lost its meaning or the entire meaning of the word would have been changed in context. Followed by pre-processing, we did word vectorization using TF-IDF. Then straight away, we used NMF for topic modeling. For topic modeling purpose, we got top 40 words to infer and conclude the topic. Upon careful consideration, the number of topics condensed to 8. Lastly, in the first phase, we make a classification model that could predict a debate belonging to which topic. The model had to be trained first, just on an already labeled dataset as inferred from above. Different classification techniques were used for classification. It provided an interface so that further any new debate could also be classified. In the second phase, we obtain a high-level summary of the steps we performed earlier. In the trend analysis, few functions combine to create a profile for the distribution of topics for a given channel and its trend analysis for the topics. Out of context windows. This function follows the principle of the sliding window method. Here, in a given window of 500 words, if after classification the number of topic related words present in the window is lower than a threshold, 7 words, then the window is set to be out of context. The sliding window length is 150 words. Through repeated sliding of this window, we traverse the entire debate and then consequently through all the debates of a channel to create a new feature called out of context minutes percentage. In the final phase, we do comparison between channels to get an overall picture. Visual representation of the findings have been plotted in the graphs using bouquet library. The results and visualizations are shown as in the slides. This is for the channel we call as N. We can see that foreign affairs peaked. The debates relating to foreign affairs peaked in the mid months of 2009-20. For channel called R, the debates peaked relating to election politics in the month of May and June for the year 2019. Similarly, for a channel called U, in the month of May 2020, debates relating to medical peaked as well. In here, we can see that we have cumulatively analyzed the debates, the percentage of debates for each topic for each channel. This graph represents the out of context windows, the percentage of out of context windows in debates over all the debates for each channel. The aforesaid profiling was done for 5 channels as shown just now. 2 channels had a lesser number of debates than compared to the other 3 and didn't have the same time period in which the trend analysis was carried out. For each channel, debates over a period of almost 3 years from December 2017 to September 20 were taken for analysis. This time period was divided into 13 equally spaced units of roughly 90 days. For each time period, the debates conducted were divided into their respective topics, and the respective percentage for that span was plotted to obtain a trend for 3 years. The trend graph for channel R, figure 2, can be interpreted as follows. From the beginning of the second quarter of 2018 to the beginning of 2020, the number of debates related to election politics increased, whereas the debates related to other topics like education and economy were not held by the channel. This stands consistent with the real-world fact, as in that interval India had its elections, which may account for the sharp increase in debates relating to election and politics. From 2020 onwards, we notice an increase in the number of debates for topics medical and foreign affairs. This also keeps in line with the reality, as it was during that interval COVID-19 outbreak hit India, and India had to consider its relations with other countries. In between, we also observe some debates related to military, which can be related to the Indo-Chinese tensions that arose during that patch. A similar line of conclusion can be drawn for other channels using the trend graph. We see that one of the most uniform distributions of debates over time can be observed for channel U. Whilst comparing the percentage debates attributed to each topic conducted by each channel over the entirety of 3 years, we note that channel R conducts most of its debates related to election politics, while channel I had its focus on medical related issues. The most balanced channel seems to be U. An out of the box feature, out of context windows, shows the percentage of windows in which the course of debates that was not related to the topic being discussed. The figure 5 plots this metric for each channel, and we see that while almost every channel has some windows, almost 18% out of the context, channel R has the most out of context windows with 22%, and channel I has the lowest with 14%. This study merely presents an example of how powerful and insightful ML and NLP techniques can prove to be when used in different fields with proper considerations. We reiterate our view that any bias in news would impact a large chunk of the population, hence it is pertinent that we have neutral and unbiased as well as a healthy discussions. This analysis is a tool to get an idea of the profile for a channel. With this, we can hope to have some form of a rough idea as to what channels subject us to. This paper has been implemented in 3 stages with the scope of improvement in 2 of them. During the classification of debates, neural networks can be used as the preferred algorithm for achieving high levels of accuracy. Secondly, to offer more insights, and n-gram profiling could also be done on the debates. This could be incorporated in the graph as well to enhance understanding around the subtopics of a group of debates in the given time frame. This type of analysis could also be cross-referenced with other countries' news channels, and the contrast or the similarity observed could help provide interesting insights. Nevertheless, this paper is capable enough to be extended across different fields and provides a framework for this type of analysis. A number of applications based on this framework could be designed. For example, similar profiling of newspapers could also be done. This paper essentially opens a portal for a bulk of data that is unlabeled, waiting to be analyzed. With this, we come to the end of our study. On behalf of my co-authors, I would like to extend a gratitude towards the committee of ICMISC for accepting our paper. Thank you, everyone.